Good morning, students. I am Savita, working as Associate Professor in the Department of Mathematics. In this video, I am going to explain Gauss Jordan method to find the solution of linear simultaneous equations. This video is useful for 5th semester BSc students. Okay. Now, what is Gauss Jordan method? Gauss Jordan method is one of the direct methods to find the solution of linear simultaneous equation, and this is a modification of Gauss elimination method. Now, what is Gauss elimination method? Gauss elimination method alli given a system of linear equations, we reduce the coefficient matrix to an upper triangular matrix using elementary row transformations only. Okay. Now, in this method, since it's a modification of Gauss elimination method, given a system of linear equations, we reduce the coefficient matrix to a diagonal matrix using elementary row transformations only. That is, elimination of unknowns is performed not in the equation below, but in the equations above also. This ultimately reduces the system to a diagonal matrix form from which the unknowns are easily obtained. Now, what is a diagonal matrix? Diagonal matrix is a square matrix where, except the diagonal elements, all other elements are 0. Diagonal elements ಅನ್ನು ಹೊರತುಪಡಿಸಿ ಉಳಿದ ಎಲ್ಲ elements 0 ಆಗಿರುತ್ತದೆ. So, Gauss Jordan method ಅಲ್ಲಿ ನಾವು coefficient matrix ಅನ್ನು diagonal matrix ಗೆ reduce ಮಾಡಿ unknowns ಅನ್ನು ಅಥವಾ variables ಅನ್ನು find out ಮಾಡಲಿಕ್ಕಿದೆ. So, you have to use elementary row transformations only. Okay. Now, let us solve one problem using this method. This is very simple. Now, consider the system of equations. Okay. So, apply Gauss Jordan method to solve the equations x plus y plus z is equal to 9, 2x minus 3y plus 4z is equal to 13, 3x plus 4y plus 5z is equal to 40. So, we have three equations in three variables x, y, z. Okay. Now, first rewrite the equations in the matrix form. Ax is equal to d, where A is a coefficient matrix. So, let us write the equations in the matrix form. 1, 1, 1, 2, minus 3, 4, 3, 4, 5. Then we have column matrix. Coefficient matrix is multiplied by capital X, which is equal to x, y, z is equal to d, where d is a column matrix 9, 13, 40. Okay. Now, the method is ಈ diagonal elements ಅನ್ನು ಹೊರತುಪಡಿಸಿ ಉಳಿದ ಎಲ್ಲ elements 0 ಮಾಡಬೇಕು using elementary row transformations. Okay. ನೀವು ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು coefficient ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡಬಹುದು. ಆಗ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಸುಲಭ ಆಗ್ತದೆ. So, let us reduce this matrix to a diagonal matrix using elementary row transformations only. Now, let me consider the second element in the first column. Now, let me make this element 0. How to make this element 0? Since the first element is equal to 1, we multiply the first row elements by 2 and subtract it from the second row elements. So, first row operation is R2 minus 2R1. Multiply the first row elements by 2 and subtract it from R2. Subtract it from the corresponding elements of the second row. R2 minus 2 R1 gives 2 minus 2 0, minus 3 minus 2 minus 5, 4 minus 2 is equal to 2, 13 minus 18 is equal to minus 5. So, first row operation is over. So, this element is equal to 0 now. Now, let us make the third element in the first column 0. Okay. Third element in the first column is equal to 3. How to make this element 0? Let us multiply the first row elements by 3 and then subtract it from the corresponding elements from R3. So the second row operation is R3 minus 3R1. So we have 3 minus 3 is equal to 0, 4 minus 3 is equal to 1, 5 minus 3 is equal to 2, 40 minus 27 is equal to 13. I hope it is clear. Okay, now, so these two elements are 0. Iga ಈ diagonal elements ಹೊರತುಪಡಿಸಿ ಉಳಿದ elements ಅನ್ನು 0 ಮಾಡುವ. Okay, so next row operation is R3 plus 1 by 5 R2. R3 plus 1 by 5 R2. Okay, this is equal to 1. Let us make this element 0. Okay, by considering this pivot element. So we need to multiply this element by 1 by 5. So idu minus 1 agtade. If I multiply minus 5 by 1 divided by 5, then I get minus 1. So R3 plus 1 by 5 R2 is equal to 0. So this element is 0. So next row operation is R3 plus 1 by 5 R2. So this element 0 aitu. Next, let me consider this element. R3 plus 1 by 5 R2. This is 2. 2 into 1 by 5 is 2 by 5. 2 plus 2 by 5 is equal to 10 plus 2, that is 12 by 5. Observe, we get 12 by 5 here. Okay, there is one more element. Now this is multiplied by 1 by 5. This element is multiplied by 1 by 5. So we have 13 minus 5 into 1 by 5, which is equal to 13 minus 1 equal to 12. So 13 minus 1 is equal to 12. First row and the second row elements are not changed. Only third row elements are changed. So third row operation is R3 plus 1 by 5 R2. I hope it is clear. Okay. Next, ಇಲ್ಲಿ minus sign ಇದೆ. ಇದು ಪಾಸಿಟಿವ್ ಮಾಡಿದರೆ ನಮಗೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸುಲಭ ಆಗುತ್ತೆ. ಸೊ ಲೆಟ್ ಮಿ ಕನ್ಸಿಡರ್ minus R2, that is second row is multiplied by minus 1. So the next row operation is minus R2. So we have 0, 5, minus 2, then plus 5. Okay, then 5 R3. Why 5 R3? ಇದೇ ಥರ ಆಪರೇಷನ್ಸ್ ಮಾಡಬೇಕು ಅಂತ ಏನಿಲ್ಲ. ನಾವು ಕೋಎಫಿಷಿಯಂಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು diagonal matrix ಗೆ reduce ಮಾಡಿದರೆ ಆಯಿತು, using elementary transformations. ಸುಲಭ ಆಗಲಿಕ್ಕೋಸ್ಕರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡುವಾಗ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡುವಾಗ ಸುಲಭ ಆಗಲಿಕ್ಕೋಸ್ಕರ 5 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೇವೆ. ಸೊ 12 divided by 5 multiplied by 5 ಆದರೆ 12 ಸಿಗ್ತದೆ. Therefore, let me consider the next row operation, that is equal to 5 R3, which gives 0, 0, 12 and 16. Clear? Okay. Now, how many elements are there? 1, 2, 3 elements, isn't it? ಈ 3 elements ನು 0 ಮಾಡಿದ್ರೆ ಆಯಿತು. 3 elements 0 ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಇದು ಮತ್ತು ಈ ಎಲಿಮೆಂಟ್ 1 ಮಾಡಿದರೆ ನಮಗೆ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸಿಗುತ್ತೆ. ಸೊ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ತುಂಬ ಸುಲಭ ಆಗುತ್ತೆ. ಇಲ್ಲದಿದ್ದರೆ ಇದನ್ನು 5 ಇದ್ದದ್ದು 5 ಇಟ್ಟು 12 ಸಹ ಹಾಗೆ ಇಟ್ಟು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡ್ಬೋದು. ಸೊ ಅದನ್ನು ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮಾಡಿ ಸಹ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಲೆಟ್ us consider the next row operation. Operation is R2 plus 1 by 6 R3. R2 plus 1 by 6 R3. So this is R2. This is multiplied by 1 by 6. 12 divided by 6 is equal to 2. Minus 2 plus 2 is equal to 0. So the next row operation is R2 plus 1 by 6 R3. So this element is equal to 0. Right? Yes. This is equal to 0. Then R2 plus 1 by 6 R3 is equal to 5 plus 60 into 1 by 6, which is equal to 15. Correct? 5 plus 10 is equal to 15. So we have 0, 5, 0 and 15. Okay. Next, let us consider 1 by 12 R3. See, 12 is common here. 0, 0, 12 and 60. So let us multiply by 1 by 12. So this row elements are equal to 0, 0, 1 and 5. So let me consider 1 by 12 R3. 1 by 12 R3 gives 0, 0, 1 and 5. Okay. Then operate 1 by 5 R2. 1 by 5 R2 gives 0, 1, 0 and 3. See, we have 5 and 15. So let us consider 1 by 5 R2. So the next row operation is 1 by 5 R2. So that simplification becomes easier. So 0, 1, 0, 3 here. Now observe, there are two elements which are not equal to 0. Except the diagonal elements, only the elements 0 ಮಾಡಬೇಕು. Therefore, the next row operation is R1 minus R2 minus R3. So R1 minus R2 minus R3, this is equal to 1. If we perform R1 minus R2 minus R3, we get 1 minus 0 which is equal to 1. Here we have 1 minus 0 that is equal to 1. Again we get 1 minus 0 minus 1 that is also equal to 0. And this element is 9 minus 3 minus 5 which is equal to 1. Ultimately the coefficient matrix is reduced to an identity matrix, that is a diagonal matrix. That is, except the diagonal elements, all other elements are equal to 0, isn't it? Now write the values. 1 into x is equal to 1. 1 into y is equal to 3. 1 into z is equal to 5. Therefore, x is equal to 1 and y is equal to 3 and z is equal to 5. Therefore, solution is obtained using Gauss Jordan method. So, Gauss Jordan method is a modification of Gauss elimination method, where we reduce the coefficient matrix to a diagonal matrix and the unknowns are found easily. Okay. So I hope you have understood Gauss Jordan method. This is also one of the direct methods to find the solution of system of linear equations, simultaneous equations. Okay. Reference book is Numerical Methods in Engineering and Science with Programs in C and C++ by Dr. B.S. Grewal. Okay, I shall stop here. Thank you.